All atoms are composed of protons, neutrons, and electrons. These three subatomic particles have different properties, and the number of each one of these helps to determine different aspects of that atom. For instance, the number of protons, that's also known as the atomic number of the atom. This determines the element. The number of protons plus the number of neutrons tells you the mass of the atom. And then finally, the number of protons minus the number of electrons determines the charge of the atom. Now, these three aspects can be put together into something called the atomic symbol. So an atomic symbol tells us what kind of element it is. This is put in the center of the atomic symbol. So for instance, if something had 6 protons, we would know it is carbon from the periodic table, and so we'd put a C in the center of the atomic symbol. To the upper left, we put the mass number. So that's the number of protons plus neutrons. And then to the upper right, that is where the charge goes. The number of protons minus the number of electrons. This can either be positive or negative, or there could be no charge. If there is no charge, that means it's a neutral atom. We just leave this blank. Now, sometimes we can also put the atomic number to the lower left-hand corner. This is represented by Z, or the number of protons. But typically, we leave this off because it is redundant with the type of element it is. Let's look at an example. So let's say we had an atom with 9 protons, 10 electrons, and 11 neutrons. Now, if we look at this, we should determine that the number of protons determines the type of element. So if it has 9 protons, that means its atomic number is 9, and that means it is fluorine. That's where we find it on the periodic table. So this is fluorine. Now the next thing, the mass number, we can determine by the number of protons plus the number of neutrons. So 9 plus 11 equals 20. So that means we would put a 20 to the upper left-hand corner. And then finally we have the charge. The charge is determined by the number of protons and the number of electrons. So it's always the number of protons minus the number of electrons. So 9 minus 10 gives us a charge of -1. This goes up to the upper right-hand corner. Now, if the charge is -1, we just put a negative. We don't put that 1 there. If it was +1, we would just put a positive there. This is our atomic symbol for an atom with 9 protons, 10 electrons, and 11 neutrons. Let's look at an example going the opposite direction. Let's say we were told that the atomic symbol is this, 88 strontium with a 2+ charge. Now, knowing that it is strontium tells us that it has 38 protons. Strontium always has 38 protons. We would find this on the periodic table. Now, this right here, this 88, that's the mass number. So mass number is protons plus neutrons. So seeing that that's 88, and we know it has 38 protons, so that means the number of neutrons is 88 minus the number of protons. So 88 minus 38 gives us 50 neutrons. And then finally it has a 2+ charge. The charge is the number of protons minus the number of electrons. Or another way to think of this is, if it was neutral, that means it has the same number of protons and electrons. That means it would have 38 electrons. But this has a +2 charge. That means it has lost 2 electrons. So it had 38 electrons, it lost 2, So that means it now has 36 electrons. So from an atomic symbol, we can determine the number of protons, neutrons, and electrons.